I'm Greg Sarjeant. I'm a professional services manager with Puppet Labs. I usually say I'm based in Chicago, but now that I'm actually here in Chicago, I have to say that I'm based in Evanston, so a little bit north of the city itself. I have been a professional services engineer. I've been with Puppet Labs for a bit more than a year and a half. I've been a professional services engineer with the company for my first year plus, and now I'm managing a portion of the professional services team based from here in Chicago. Prior to that, I actually worked down the street at Grubhub, where we used Puppet, first open source, and then Puppet Enterprise, and that was sort of how I got bit by the bug. So before we get going, I'd like to thank our sponsors, first of all. SolidFire, thank you very much for sponsoring the event. They're in the back. And of course, thank you to Google for hosting us and for providing the lovely space. I think last year it was pouring, as I recall, and very gloomy. So today we have windows that don't take advantage of the windows during talks, but at times after, between talks, enjoy the skyline. If you hear things that are of interest, you want to let people know about the camp, use the hashtag PuppetCamp to tell everyone on Twitter what's going on. And one other note about the talks, if we could just take a moment briefly to silence our phones and just out of respect for the speakers, make sure that we don't have phones ringing. I know a lot of us are probably going to be getting email and urgent alerts during the day. And vibration is fine, but if we can minimize sound, that would be great. So I'd like to just start off, just to get a feel. As Kara mentioned, usually at Puppet camps we see a fairly wide range of experience levels with Puppet and automation in general. So I'd like to just sort of start off with some poll questions to ask people. So who here is using Puppet today? Just a quick show of hands. Okay, so it's like about half folks. Of those who are using Puppet or not, how many of you are fairly new to Puppet, would you say, maybe the last 3 to 6 months? So, okay, great. Is anyone using some other automation tool today? And if so, some question, did you build that tool yourself? Okay. So we'll talk about, during the course of the day, some ways in which using a tool like Puppet can help sort of ease some of the burden that comes with maintaining our own custom-built tools. And then finally, how many people here aren't doing any automation at all today? Okay. Well, you should get some fantastic ideas from some of the talks that you'll hear today, and we hopefully can show a better way forward than entirely manually doing configuration management. So there's a lot of talk about technology and automation and all of the sort of I guess the technological aspects of what we do, and it's easy sometimes to lose sight of the human reasons behind what it is that we do and what makes Puppet important and automation important. And really fundamentally, what this is all about is that being a systems administrator, it is a difficult job. And that's, our founder Luke Knies was a systems administrator, recognized that the job was difficult, wrote Puppet to ease that systems administration burden. I've been thinking a lot about this slide the last couple of days. This troll has it pretty good. It looks like he's kind of hanging out under his bridge. And I know that sort of the troll under the bridge has been the sort of stereotypical metaphor of the systems administrator. From my days in systems administration, I think we could extend this metaphor a little bit. I think there should be some trucks, some heavy trucks kind of going over the bridge in sort of an endless stream, and rocks falling down from the bridge while the troll is trying to sort of pick them up out of the river and off the sides of the bridge and put them all back together. And maybe there's some other trolls coming down wearing suits in gondolas with megaphones, sort of yelling at the troll, telling him how he should be putting the bridge together more quickly. And can we make it a drawbridge, maybe? Because we're going to have some bigger boats coming down, but don't interrupt the trucks while you make the bridge a drawbridge. That's how I kind of remember being a systems administrator. I didn't get a lot of time to sort of hang out under the bridge. And that's really, I think, the way the technology is going. Our bridges are really just going to get more and more complicated. Our lives are going to get more and more hectic. The infrastructure that we build is more critical than it's ever been. There are only going to be more servers. There's only going to be more services running on those servers. And we really need to get away from the notion of single trolls living under bridges, patching them up as things go by, and really become a lot more agile with how we do our technology. Another thing that's happened with this is that companies have begun to realize that the technology, whatever it is that we do, isn't ancillary to our our job. We are all, in some way or another, becoming technology companies, and if we aren't today a technology company, we're going to be. And if we're not using technology to our own advantage, what we find is that our competitors are going to do that and take away our business from us. And this is kind of in contrast to what we saw in the late 90s and the early 2000s. A lot of people reached the conclusion that technology isn't strategic, it's not really what we do. We're going to outsource all that technology stuff and focus on what the real business is about. And that's not what we're seeing anymore. People have realized that regardless of what it is, the technology is a strategic part of the business, and we're seeing a lot of people bring technology back in-house. And with that comes a need to be able to manage those technology infrastructures in-house and not just shunt it off to someone else. But there's more to this than just the raw technology, right? As we're bringing, the reason that people are bringing technology back in-house, the thing that's really driving this movement is the acknowledgement that the technology isn't just there for its own sake. We need to direct our technology towards the ends of our businesses. And so as we're bringing technology back in-house, as we're building up infrastructure, as we're building up all of these systems, what we need to be focused on are both sort of the ends to which we're bringing that technology to bear, right? When I'm selling a product or a service and I need technology in support of that, and really the efficiency with which we apply the technology to those ends. If I'm not using technology wisely, I'm just throwing money away. I'm building up a big server room for the sake of having a big server room. I'm not actually doing something that makes the business better. There are a couple of things that we focus on as we sort of think about these things. And really there are four primary things. There's speed, which is affects our time to market. How quickly can I get new infrastructure provisioned? How quickly can I make changes to my infrastructure to react to changes in the market? There's agility. So if I want to make if I make a decision today and I realize tomorrow that it was the wrong decision, I want to be able to correct that very quickly. Focus. So again, not just throwing a bunch of technology at a problem because we've heard that servers are great, but really thinking about why it is that I'm making an investment in technology. And then finally, alignment, right? There's the focus on what the business is doing, and also alignment with the needs of the business. Do I need to burst in response to demand at unpredictable times? Do I have a relatively constant stream of demand? Do I have high reliability requirements? All of these sorts of decisions that go into how we implement technology. So there are a number of ways in which people have begun to sort of answer a lot of these questions through technology. There can't possibly be anyone in the room who hasn't heard the word cloud at some point in the not too distant past. Cloud has become a fairly overloaded term, but there is no denying that the cloud, however we understand it, is a dramatic change in how we view technology and how we view infrastructure. And now, to what used to be sort of a long, drawn-out procurement cycle for bringing in new hardware and having to put servers in racks and configure them, is a matter of mouse clicks to provision tens or hundreds or thousands of new servers, and suddenly we have to do something with all of these servers, right? But there are a couple of specific technology or specific practices that the cloud enables that really started to have a big impact across industries. The first of these is sort of software as a service. So companies, while we're not outsourcing technology itself, using a lot of these SaaS providers, we can outsource things that are technological in nature but aren't critical to the business. Everyone needs a mail server, right? File serving, things like that that are a little bit more, a little less strategic to the business. We can use SaaS providers for. And then infrastructure as a service really enables companies to create actual infrastructure, servers on demand. Actual is perhaps the wrong word because there tend to be virtual servers on demand as needed. Another large and more recent movement has been the movement towards immutable infrastructure. And so one of the questions that has long plagued, I guess, systems administrators and technology companies in general is that I can get all of this infrastructure provision, I can come up with good change control policies, and I can change my production servers, but no matter how good those policies are, no matter how good that automation is, it's still a very perilous operation to take a production running server and apply operating system patches or upgrade core components, right? Like there's just no world right now, or there hasn't been a world right now in which that's not an operation that causes some number of people to lose sleep. Immutable infrastructure is a pretty popular answer or attempt to answer that question, where when we make a deployment, when we make a release, what we're releasing is in fact the entire infrastructure. And I have containers, metaphors, to which I deploy applications. When I want to make a change to that application, I don't change the container, I don't change the infrastructure, I just deploy an entirely new, pre-configured, pre-built container, redirect away from the old, point to the new, and I already know that what I'm deploying is something that's been through some sort of a release cycle and is a functioning, self-contained unit. I don't have to worry about testing my upgrade in a test environment that didn't exactly match my production environment and not finding out until 3 in the morning that it was actually a critical difference between the two. We actually get a lot of questions at Puppet Labs about the implications on this move towards immutable infrastructure and containerization for configuration management. And it's a pretty interesting question. If the thing that I'm deploying, if the unit of infrastructure is no longer something that I want to change, then do we need configuration management tools? And I'd say yes, we do, actually. And there are a couple of places where something like Puppet is very helpful, even in a containerized and immutable world. The first is obviously in building up those initial images. So it's good to have a nice, well-defined, centralized configuration management system to help build up the containers that you're going to deploy immutably. And then also, those systems will themselves run on other hardware and other servers, and having configuration management tools to maintain the platform on which the immutable infrastructure runs is also very valuable. Outside of the straight technological movements that we're seeing, there are also organizational movements, and the primary one that we've all been familiar with is DevOps. And so the DevOps movement, again, it's another word like cloud. It can mean anything to anyone in a lot of ways. But what I have noted is that really successful IT organizations that are adopting DevOps practices are focused on really aligning the operations technical side of the practice with the business side of the practice much more comprehensively than we've seen in the past. And so this has sort of been a feature of Agile software development for some time. Agile Scrum teams bringing in experts from the organization, bringing in business partners, helping kind of guide software development much more strategically in line with the business. But the systems administration side of the house has sort of been off to the side in those worlds. And in the DevOps movement, we're really bringing the systems administrators into that as well and making it a more comprehensive way to run businesses. Puppet Labs, every year we release a sort of state of DevOps report. We survey the industry, we get a lot of really good quantitative data from people about how they're sort of making this DevOps journey, how it's affecting them. We sort of uniformly find that companies that adopt these agile DevOps practices are successful companies. They're more profitable, they have higher market capitalization, and this is really borne out in this report. So if any of you are sort of making this movement, switching to a DevOps culture and sort of struggling to present that case, this report is actually a very useful tool for that. You can just go to the Puppet Labs website, look up the State of DevOps report. The 2014 report is out there now. The 2015 will be coming out in a few months. So we have a couple of major partners, I guess, people who have been using Puppet to solve some of these problems in the real world at large scale. A number of them have spoken at PuppetConf, have delivered speeches, presentations. One of the big ones is Getty Images. And I don't know if anyone here was at PuppetConf or watched the PuppetConf talks. They gave a keynote speech there, and Getty has a lot of the same infrastructure needs that a lot of us have been talking about and considering. They have a number of environments, dev environment, test environment, production environment, want to be able to standardize those environments and really have a reliable delivery pipeline. And that's, again, long been a feature of software development. We've realized and recognized the need to standardize the infrastructure in those environments as much as we possibly can. And that's what Getty has been using Puppet to do. They started with open source Puppet back in 2011. Then they bought a 250 node license for Puppet Enterprise to give that a try, and have since expanded the Puppet Enterprise installation there, and have really been, through the use of Puppet, both open source and enterprise, been able to standardize that infrastructure and really increase the speed and reliability with which they're able to release code. There are a number of other cases that we can dig into, Salesforce, Department of Payment, you see here. a number of people using Puppet to solve some of these problems. Right? So Puppet, for those of you who are just new to it and getting used to it, what are we all about? We're really about automating that configuration management. That's what we do. It's our bread and butter. We take the repetitive, sort of manual, and sometimes perilous tasks away from human beings and put them on computers that are ideally suited to perform those tasks in a reliable and efficient manner. So let's talk a little bit about, in more detail, what Puppet does and how it does it. We're all about automation. We allow you to make sort of rapid changes, but not just rapid changes, repeatable changes. So you'll hear the phrase infrastructure as code used a lot when speaking about Puppet and configuration management systems. What the Puppet model is we codify, we write code to describe what the infrastructure is that we want, and then we allow Puppet agents to apply those changes to systems. And this allows us to more quickly apply changes to systems. It gives us increased productivity because it's computers that are doing the rote work and not people, and people can focus on the more creative endeavors. And you get a lot better insight to your systems when you move to Puppet than having manual automation or a manual configuration being done, because Puppet reports back any changes in state that it finds on any run. In particular, Puppet will automate the configuration of a lot of the standard things that you're used to having to automate in systems, right? Users and groups and DNS and packages, services, all of this sort of thing can be automated through the use of Puppet modules. And for the things that you see on the screen here, there are standard modules. Some of them are built in, some of them are provided by the community. We have a very active module development community, both people outside of Puppet Labs and people inside of Puppet Labs who are module developers, and provide a lot of extensions to Puppet itself to automate other things that aren't built into the language. The way that we model configuration differs from what most people are used to from automation traditionally. We use a declarative approach to define the state of the system that we want to see. So rather than writing sort of a procedural runbook to tell the system how to put it into the correct configuration, in Puppet you just use our domain-specific language to describe the state that you want to be enforced, and the Puppet agent will then apply that state. This was, for me, it was the biggest sort of conceptual leap that I had to make. I kept wanting to tell Puppet what to do. And once I sort of shifted my mindset from just describing to Puppet what I wanted my system to look like, it became a lot clearer to me. By doing this, you can define the various portions of your infrastructure that you want Puppet to manage once, and Puppet will then apply those changes repeatedly across various operating systems and across various portions of your infrastructure, and it handles all of those details for you. After you've made those definitions, you don't have to apply them in production immediately. You can actually do what we call a no-op run. It's kind of a test flight of the Puppet run to verify what's going to happen before you apply changes in production and make them live. And so this, again, gives a little bit of that sanity check, a little bit of that confidence before applying something in production that we're not going to take something down. After we've done that test flight, then Puppet can do an enforcing run and actually coerce the system into the configuration that has been defined in your Puppet code. After it makes those changes, or doesn't make those changes depending on the state of the system, it will report back to the Puppet master, or you can create integrations with third-party reporting tools, anything that happened. And so this is where you get that insight and that extra visibility to what's going on in your system. Puppet will tell you every time it makes a change, this is what changed, this was the state that the system was in, this is what I did to get it into the state that you told me to have it in. So that's at a high level sort of what Puppet does. We talk a little bit about how it works at this point for those who are getting familiar with it. So Puppet exposes a domain-specific language, DSL, which is what we use to describe all of the various resources that Puppet manages. And you can see it's a very simple language, it's very simple code that we provide. And all that we're doing here is defining a resource that we want Puppet to manage. In this case, it's the SSHD config file. And we're setting the values of all of the attributes on that file that we want Puppet to do. So you can see that there's nothing here about invoking commands to change ownership or doing text replacement to set the contents of the file. We're strictly setting the values of the things specifying the values of the things we want Puppet to manage. Underneath, Puppet will handle all of the particulars of figuring out, is this a Red Hat system? Is it a Solaris system? Is it a Ubuntu system? In this case, it likely wouldn't be a Windows system, but if it were, you could have Puppet managing the paths on Windows, and it will take care of all those particulars. You don't have to write new code for this for every sort of system that Puppet would run on. The basic primitives, that was a file resource. Things like files and packages and service, you'll often hear the package file service pattern referred to as you're learning Puppet. Users, groups, that sort of thing are built into the core of Puppet. So when you install Puppet on your system, you can start working with these resources right out of the box, and you can create relationships between those resources. Right? So in this case, when you're configuring a service such as SSH, we want to have the package on there first, and then we update the config file after we put the package on. And then we start the service after the config file has been updated and has the settings that we want. So all of that sort of work can be done inside of Puppet code, and you can just define those dependency relationships. Windows is a first-class citizen in Puppet. So I know that there's been, in the past, there's been some question about how robustly we support Windows. There are a number of, in the last 6 months to a year, we've released a number of very strong Windows modules. There's a Windows module pack now. There's a SQL Server module. We have a robust ACL module, so you can work with Windows file permissions in a Windows native way instead of trying to sort of back in to more of a Unix permissions and ownership model. Registry keys, there's a reboot module. Reboots are still a fact of life on Windows, but we can handle those very gracefully in Puppet. And you can also manage things like IIS using Puppet types and providers, and using the same sort of DSL, the same sort of language that you'd be accustomed to if you've been using Puppet on the Linux side. And so you get that consistency regardless of whether you're using Linux or Windows. Regardless of whether you're using your own modules or modules that you pull down from the Forge, the way that your state gets defined or gets enforced on a system is the same in all cases. We're going to look at the case where there is a Puppet master and agents on that master. Every 30 minutes, by default, and that's a configurable parameter, agents on your managed nodes will check into a Puppet master. The agent, when it does this, will submit facts, and it's about 50 to 100 bits of information to just identify that node. It's things like the host name, the IP address, the operating system that's installed, that kind of information. Based on the identity of the server and those facts, the Puppet master, which is the Puppet server component that you see here, will compile a catalog. And that catalog is what defines the state that system should be in. It sends that catalog back to the agent node, and the agent will then go resource by resource through that catalog, see what the Puppet master says the state of that resource should be, compare it to the state of that resource on the system. If they're already the same, Puppet does nothing. If there is a difference, then Puppet will coerce the system into the state that's defined in the catalog. Once it has made those changes, the agent then reports back out about all of the changes that it made. So again, you get that visibility to what has happened. I get a lot of questions about the reporting side of it. Compliance organizations really like to know, hey, what changed and when and why. It's important. A lot of times, some people will actually just run Puppet agents in the no-op mode, just as a matter of course, just to know whether something changed, and not having any interest in actually making those changes, but more monitoring the system and knowing that something shouldn't have changed, but that they'll get a report if it does. There's a PuppetDB component, which is where that report data gets stored. And PuppetDB is really the focus, the central point where we store all data about the Puppet infrastructure. So it has everything about the configurations of your servers. It has the facts. The last time every server submitted its facts, those get stored in PuppetDB. All the reports get stored in PuppetDB. It's really what we use for Puppet and Puppet Enterprise's data storage, and it's what we use for all of our reporting and all of our analysis on the back end. It's a PostgreSQL database that has a Java application on top of it that is used to interact with that database. You've heard me use the term Puppet Master a lot, and it's because it's a term that's ingrained in my head. We have a new sort of next-gen Puppet server, and Puppet server is really the term that we're using for what has traditionally been known as the master component. And we've moved the server component away from Ruby. It's no longer a Rails application. It's based on a JVM stack now. And then we did this for a number of reasons. The primary ones were scalability. We've had a lot of requests for, hey, how do I scale out beyond thousands of nodes to tens of thousands of nodes to hundreds of thousands of nodes? moving to a JVM-based system gives us more opportunities for scalability. It's much faster than the original implementation had been. My mind just went blank. But it allows us to give much more insight to what's going on inside the server than was possible before when it was a Ruby applications. There's a lot of JVM instrumentation that's already out there, and we can get a lot of good analysis and metrics out of the Puppet server. It's also, as we'll see a little bit later, the foundation for a more composable approach to building the Puppet server services. MCollective is our orchestration engine, and I want to stop here for a moment. There's been some, I don't know how many people here follow the PE users or the PE announcements mailing lists, but in Puppet Enterprise 3.8, there was an announcement that's about the future of live management in MCollective, and there's been some confusion about those two. So I want to reiterate, first of all, MCollective is not going anywhere. So MCollective is sort of the foundation of our orchestration engine today. In PE 3.8, the live management feature of Puppet Enterprise, which is a front end on top of MCollective, has been deprecated, but MCollective itself is still the foundation of our orchestration and application delivery efforts. In future releases of Puppet Enterprise, we're sort of reassessing how we deal with orchestration more globally, and so Puppet's view traditionally has been at the node level, managing the configuration of a single node. If you want to manage multiple nodes, you define multiple individual nodes. We're starting to extend that to go beyond managing the configuration of a single node to managing the configuration of an infrastructure, and what does it mean to do that sort of elegantly in Puppet. And so you'll see some new approaches to that coming in the later PE releases that will be supplanting the live management interface. But MCollective, which is the engine underneath it, will still be here. And MCollective can be used to do a number of things. It can do real-time discovery of the nodes in your infrastructure. It can do ad hoc execution of commands. It can do initiate Puppet runs ad hoc. People use it to deliver applications to their servers on demand in response to events. So this is sort of our glue code, if you will, orchestration layer on top of Puppet. Hyra is the data abstraction backend that we use. So one of the benefits of going to an infrastructure as code model is that we can define the infrastructure portions of our, the common portions of our infrastructure once, and we can abstract away the data that varies from environment to environment and pull that into a different backend, such as Hyra. And so this allows us to create classes that accept variables for the values that change in Puppet code without actually having to change the code underneath every time I want to maintain the same file on a dev system, a test system, or a production system. So by splitting out data from code, we're able to do some quicker iterations. I don't have to worry about the fact, I don't have to worry about whether my infrastructure code itself changed as I move from environment to environment. I just have to make sure I have the right passwords, I have the right permissions in place, I'm using the correct service account for dev and production. We also will frequently find that there are organizations that are interested in having one team who's able to maintain the Puppet code itself, and there are different teams who are interested in maintaining the values of the data that gets fed into those systems from environment to environment. This is especially true in sort of sensitive organizations where the dev team doesn't need to know the production passwords and that sort of thing. By splitting that data off, you can make those distinctions a lot more elegantly and have different people in charge of different portions of your code base. For deploying the code, how many of you are familiar with the tool called R10K? Okay, great. So R10K is a tool that was developed by people at Puppet Labs. It's been maintained by some of our developers, some of the professional services engineers. And what it does is it eases the process of deploying code from a version control system to your production Puppet masters. Without getting into too much detail, it basically maps branches of a Git repository to environments on your Puppet master, so I can have in Git a dev branch, a test branch, and a production branch where those bits of Puppet code are isolated from one another, and they will correspond to dev, test, and production directories now on my Puppet master, again, isolating that code at the infrastructure level at each of those layers. On the open source side, we've recently released Puppet 4.0. This is a major update to the language. It's a major, it's actually a very exciting change, and it's a major event for us. The open source platform, the open source offering, is really the standard for all of our offerings. It's the foundation upon which Puppet Enterprise is built. It's what the future direction of our company is. It's primarily right now you'll see these changes implemented mostly on the agent side, and they're language-facing changes and well, primarily language-facing changes and some scaling and cleanup changes. So you'll see a lot of innovation with Puppet 4. Who here is using open source Puppet, and if so, have you used Puppet 4 in your organizations yet? Okay, so definitely I would strongly encourage giving it a look. We'll go into a little bit more detail about what is in Puppet 4 and what we've changed. There are language enhancements to address some fairly common requests from the Puppet community and from our user base. We've rewritten the parser. We've added a lot of consistency. We've cleaned up error handling. I know one of the common bits of feedback that we get is that our error messages can be somewhat opaque from time to time. We've done a lot to improve that in Puppet 4. The language is more strict, so a lot of things that we've sort of been pushing off to these validate functions are now handled through typing of parameters and that sort of thing. So you see a lot of changes that have been requested. Iteration has come to the DSL now, so things that we used to do with create resources and inline template usage and that sort of thing, you can now actually truly iterate through things in the DSL. We'll go into a little detail about some of these enhancements now. So you can optionally specify types for parameters in your Puppet code now. So you can see here we have an array of strings as a message. So prior to Puppet 4, if you wanted to verify that this was an array and that it was strings, you had to add a lot of extra Puppet code to your manifest to do those checks before actually running the code. And it clutters up your manifest and it clutters up the code. Now, because we have some typing in there and I'm hitting the wrong button, we don't have to worry about cluttering up our Puppet code with all this validation stuff, and it's a lot easier to just see what the code is trying to accomplish. Iteration, so that we can now iterate through entities in the language using a very Ruby-ish syntax. This is familiar probably to anyone who's used Ruby. So if I have arrays, if I have hashes, I can iterate through each item and send out a notice of what the value is or operate on those values within the DSL. So I don't have to offload those iteration operations to custom Ruby code anymore or the create resources function and hierarchy mappings and that sort of thing. This is usually a concern for things like users, virtual hosts on Apache systems, things where I don't know until the time when I'm actually building a catalog how many of a thing I'm going to want to manage on my system. So you heard me mention before that the new sort of Puppet server is going to be the foundation of a more composable approach to Puppet server components, where you'll see, whereas the changes that come into open source Puppet tend to focus more on the agent side, on the Puppet Enterprise side, our changes focus more on the server side, and you're going to see a lot of our innovation on the server side happen in Puppet Enterprise, and you can really think of PE as sort of a layer on top of that open source foundation, right? So the Puppet open source component, the PE core, they're all built off of the open source offerings, that they are a fundamental part of the PE ecosystem. On top of that, we're moving away from this sort of larger scale, heavier monolithic model to a more app-based model where there are different Puppet Enterprise apps to target specific functions that people have generally associated with Puppet Enterprise. So there's a node manager, a configuration manager, code manager. Some of these names are still up for revision, and we'll get into the details about what a number of these things mean on the coming slides. But conceptually, I just wanted to sort of make sure that we all are thinking of Puppet Enterprise as a layer of applications on top of the open source foundation components. So what do some of these applications do? The node manager is what we've traditionally called the node classifier in the past, and it's a rules-based engine to define what classes, what sorts of functionality should be mapped to various Puppet agent nodes. This may look familiar. Is anyone here using PE 3.7 or later today? So this looks very similar to the node manager that is in 3.7. And we're moving away from a model, sort of traditionally we've mapped classification to host names. We're moving to a much more rules-based model. So if it's a Linux server in this subnet, it's a web server, and that kind of thing. So we can make a lot more dynamic and a lot more kind of larger scale, more functional decisions about what the server is using the node manager. Some of the things that you can manage with Puppet include Docker. So we put a lot of work into, I talked a little bit at the beginning about where configuration management fits in a sort of containerized, immutable world. We have a Docker module that can be used to manage Docker instances, Docker entities, easily launch your Docker containers, bring them down, deploy new Docker containers using Puppet code. So this is kind of where that interface is between configuration management and immutable infrastructure. We can use the Puppet DSL and our Puppet configuration management engine to manage our Docker containers and Docker instances. You can also use Puppet to manage AWS entities. There's an AWS module that exists today. We use it fairly heavily in-house. And you can manage all manner of AWS entities to automate the provisioning and tuning and scaling of your AWS infrastructure. So here you can see some examples of using our modules to manage security groups and load balancers. You can also manage your cloud watch alarms. I'm now falling into the part where I read the things on the bottom of the slide to you. So the punchline here is that you can manage all of these various entities in AWS through Puppet code. So again, one of the big questions that we get, and I got this a lot in the field in pro services, they all revolve around, there are all these technologies out there. There's cloud technologies, there's AWS, there's Docker, there's monitoring, there's Puppet, there's all of these various pieces. Where do I draw the lines? Where do they fit? Where are the boundaries? How do I stitch all these things together in a way that makes sense? And this is one way in which you can sort of approach these questions. If you have an AWS infrastructure and you want to manage it using Puppet, you can actually use your Puppet code to manage not just the things that are on those nodes themselves, but the nodes themselves, and then how they scale, and how the load balancing works, and how the DNS resolution works from AWS. Because this is all done in Puppet code, you can bring the same testing tools to bear on your AWS infrastructure that you can on usual Puppet code. So I can write spec tests to verify that all of my web servers are in the US West 1 region and are of the T2 microtype before I provision them. And same thing for application servers, database servers. So I can actually write RSpec tests before I go and provision a bunch of large web servers accidentally. I can run the test to make sure that, yep, everything that I'm trying to provision on AWS is what it should be, and I'm not going to get hit with a huge bill as a surprise when I automate the provisioning of these systems. We're also doing a lot more with bare metal provisioning, and this does also extend to sort of VM images as well, but we have an engine now for bare metal provisioning. It's a sort of Pixie boot based process whereby we have tools that will go out, discover any bare metal systems in your infrastructure, and allow you to write rules to define which systems should have which operating systems and what initial configuration put into place on them. This was another, been driven by requests from the community. It's something that we get a lot when we're out in the field doing Puppet implementations. Right? It's great to have a tool like Puppet that can manage your infrastructure once those servers are provisioned, but it'd really be nice to also have something to do that first step to get the servers configured in the first place. And that's something that we're addressing now through these bare metal provisioning tools. So we can now, with a Puppet Enterprise infrastructure, have these tools in place, spin up new bare metal hardware, get the operating system on there, bring them under Puppet Enterprise control, or bring them under Puppet control, and then have Puppet running on the servers and automating the configuration just as a single operation. So you no longer have to worry about what do I do first before I get the Puppet agent on my hardware. The code manager that I mentioned before for the application is our formalization of R10K. So another common request, we use R10K all over the place. A lot of people use R10K. It has not been, until fairly recently, an actual supported product of Puppet Labs. It's something that people have been working on in the community and people have been working on the side. A lot of people have requested support for R10K or something like it, because it becomes a fairly central part of your configuration management solution when you put it in place. It is now, it's coming as this code manager application. It's actually a part of PE 3.8 today, and will continue to be sort of a first-class member of the Puppet Enterprise delivery throughout the future. And so I mentioned this sort of before. What R10K does is map branches of Git repositories to environments on your Puppet Enterprise server, so that you can then you can use your Git repository, your Git structure, to define your software delivery lifecycle for infrastructure code. And so I can isolate dev, test, production code in my Git repository. R10K will manage synchronizing that code to my Puppet master, and it can do so in response to pull requests being merged, or it can be done on demand. You can set up orchestration tasks to trigger the synchronization. There's a number of different ways in which that can be controlled. But what this really does is allow you to ease the creation of software delivery pipelines for infrastructure code. We have put a lot of focus on role-based access control. Again, a lot of people have had requests about giving different sorts of people, different groups of people, access to different portions of the Puppet infrastructure. We have this right now in the node manager component, and it's going to be a fundamental piece of all of the Puppet Enterprise components coming in the future. So we're going to enable organizations to grant different groups of people different levels of ability to manage the various Puppet Enterprise tools. It integrates with AD and OpenLDAP, so it's all LDAP-based services. So you can use the same security groups and security model that you use to model your organization as a whole to also model access to the Puppet Enterprise components. I mentioned as one of the benefits of the new sort of JVM-based Puppet server that it enables a lot more visibility and insight into what's going on under the hood in Puppet. As a result of that, we're able to expose a lot more sophisticated reporting in Puppet server. So there's a metrics service and there's a profile that will return information about things like number of active requests and how long those requests take, execution times, compilation load, things that people are interested in, especially as we scale our Puppet infrastructures, finding where the bottlenecks are and then helping to sort of target where we can make changes and add efficiency to the code, or when we need to throw more hardware and resources at the infrastructure to actually scale in response to demand. These reports, there's a pre-packaged GraphHive report, but we can also export this information to any number of sort of third-party reporting backends. You can integrate them into your existing reporting infrastructure as well, and have this kind of visibility to what's going on at the Puppet server level in your organization. Once you have that visibility to what's going on in the Puppet master itself, you also want to have visibility to what's going on in your infrastructure and what the Puppet master is doing. So there's an events inspector that's part of Puppet Enterprise that provides that reporting at the server and environment level. So I can see at a glance through this view how many runs have there been over the last number of days. Of those, how many times did Puppet change something? How many times was nothing changed? How many of the runs failed? Right, so I can get a sort of high-level view here of what's going on across my infrastructure, and then you can also drill down into any of these, and you can see everything that happened today, and you can find all of the changed nodes, and you can drill into an individual node and see what resources were changed on the last run. So you can really dig in to details. If you see something anomalous here, something you don't expect, suddenly you get a big red bar and everything's failing, or suddenly you get a bunch of unexpected changes, you can really drill in and see what it is that's changing, what's causing the failure, and get that information very quickly through this event inspector. We've been really formalizing our support, the Puppet Forge, and really kind of fleshing that out. And there's a couple of things that people have requested a lot from the Forge. The Forge is a wonderful resource, and I want to pause for just a moment. Before, I say this everywhere I go, and anytime I'm on an engagement, before you write a single line of Puppet code, your first instinct should always be go to the Forge and see if there's already a module out there that does what it is that you want to do. I will confess, I did not do this. I spent maybe a year at Grubhub writing code for things that were already on the Forge, and I felt very sad when I went to Puppet Labs and learned that I should have done that, so sorry. Go to the Forge, see what's already out there. A couple of things that people have asked for is some way of judging the quality of a module that's on the Forge. That's a pretty common question. We now have 2 ways that you can get a pretty good sense for whether a module is something that you would want to use in your production infrastructure. The first is there are a number of Puppet-supported modules, and these are modules that are have guaranteed SLAs. They're supported by Puppet Labs. They're tested on Puppet Enterprise. They have supportability matrices on our website, so if you go to puppetlabs.com and look up the Puppet-supported modules, you can see which operating systems each of those modules is officially supported on. And if you're a Puppet Enterprise customer, those modules are covered under your support contract. So those are the formally supported modules. We also have what we call Puppet-approved modules, and these are modules that aren't written by Puppet Labs, but they're written by members of the community, and they adhere to Puppet Labs standards for style and robustness and code clarity and documentation. They're updated regularly, and so the approved designation gives us a way to define what makes a good module and allows us to give an endorsement to those members of our community who have written good modules that we're confident encouraging you to use in your organization. So go to the Forge. If you have a question about which modules to use, I usually just look for the supported module or then look for an approved module, and that's the one that I'll tend to use. So there's a lot here with Puppet. There's a lot of things that we can do to automate. But one of the things that has sort of struck me over the last few years being at Puppet, this is all changing very quickly. All of there's the talk of immutable infrastructure, which is a lot more active than it was even a year ago. The way that people are using cloud technologies and public and private and hybrid cloud technologies, all of this is changing, and we're really kind of just still learning our way. We're just beginning sort of down this road of automation and configuration management and the DevOps culture. And Puppet Labs is taking an active role in trying to help us, and trying to help make that journey. We have a fantastic education team at Puppet Labs, and we put together a learning site where you can go online and get access to all kinds of various learning materials. There's some online video courses. There are short 3, 6, and 9 hour more formal courses. There's there's a learning VM that you can pull down and do a sort of self-guided introduction to Puppet for yourself. And a lot of these things are free. So go to the puppetlabs.com.learn site, take advantage of all of the material that our education team has put together. They're just fantastic. As I said before, go to the Forge. Every time you want to manage something, see if there's something on the Forge that does it for you, and you get the benefit of using a module that's highly visible, that's being contributed to by members of the community, by people at Puppet Labs. You can really find that a lot of the work that you want to do with Puppet has already been done for you and has been on the Forge. And if you don't see what you want on the Forge, and you do find yourself writing a new module, by all means, feel free to bring it to the Forge and give back to the community in that way. Alongside the puppetlabs.com learn site and the more informal teaching tools, there are formal classroom trainings. We have 3 primary ones right now. There's Fundamentals, which is really the foundation course, learning about how to bring Puppet into your organization. And that's forks into sort of 2 more advanced levels. There's a practitioner course that focuses more on the module development side and more advanced topics in module development. And then there's an architect course that is focused on people who are implementing the Puppet infrastructure itself, the Puppet DB server, the Puppet master, MCollective, and how to tune and scale all of those pieces. And then check out the docs. We have a good doc site. It's received a facelift recently. It's easier to navigate. We have very, very good documentation, and the documentation itself is also open source. So if you are using the documentation and you see a bug, you see an error, something you want to fix, something you want to enhance, the docs team loves to get pull requests. So feel free to send them along. It's a really nice way to start contributing to the community if you're interested in doing that, but don't want to dive right into modules or the Puppet code base itself. And if you want to take a more active role in making Puppet better, you can look into our test pilot program. The test pilot program is fantastic. I actually have participated in it a number of times internally. We'll call you up. You can spend an hour working with one of our people and really get a chance to try out what's coming, the new features of Puppet, see the future of the language. If you join the Test Pilots program, you'll get a fantastic t-shirt. That's how you get it. You get a fantastic t-shirt. They're the best t-shirts we have. You get a gift card for participating in any of these. So if you're not motivated by helping chart the future course of Puppet, there's also good swag to be had as a Puppet Test Pilot. And then there's a lot of entry points to get involved. We have an ask.puppetlabs.com site. It's kind of a forum sort of site where people can ask questions and people can answer. There are mailing lists. There's an IRC channel. You can fix bugs. You can contribute code. Go to the community site at puppetlabs.com and look for all of these various entry points into the community. And then if you want to more formally contribute to Puppet Labs, we're also hiring. So we have offices in a number of locations, but we also have a number of jobs. You heard a number of us say that we're working here out of Chicago. I mentioned earlier I had been a professional services engineer here and no longer am. So there's a professional services engineer spot in Chicago. We're always hiring. Go to the career site, and if you'd like to, if something catches your fancy and you're interested in joining the team, we'd love to have you. And then last but not least, PuppetConf is coming to Portland, October 5th through 9th. So there are a couple of more days left to submit papers. The call for papers is still open. So if you're interested in speaking at PuppetConf, if there's a topic that you'd like to share with the community, get those proposals in the next couple of days. And even if you're not interested in talking, come on out to Portland. It's a lovely city. It's beautiful in the fall. You can kind of get a sense for the environment around Puppet Labs and hang out with people in the community and people from Puppet Labs at the conference itself. So that's it. I've run a little bit late. So does anyone have any questions before we move to the next talk? One or two? What's that?
You can do questions as long as you read them.
Okay, sure. Is there any questions? Puppet, Portland? What's it do on a lovely day in Chicago? Or Evanston? Evanston's great. Yes?
You mentioned Git integration. Are those predefined commands, or can you define them farther out? Our use cases, we go through Garrett first, which is a Google-based kind of gateway for Git. So it's kind of like a change review control thing, code quality thing. But the commands was almost completely different from a normal commit. So is there a way to define that?
So the question was, I mentioned Git integration, and is that integration customizable, or are the commands fairly hard-coded? In this particular use case, you're using Garrett as sort of a gateway to Git and would like to integrate at the Garrett layer rather than the Git layer. Right now, the commands themselves aren't hard-coded, but it is targeted towards version control systems. So you can choose from things like Git and Subversion and that sort of thing, but it's not built to interact directly with tools like Garrett. But it's actually an excellent suggestion as well, and one that I will not bring back. Any other questions? Okay. Well, thank you very much.
Thanks, Greg.